Hi, you guys. I hope you all had a wonderful break and holidays, Christmas, and New Year's. I know I certainly did. I am missing being back and teaching you guys, but I've been very busy. I wanted to start just by saying thank you so much to whoever is subbing for me. It is not always a fun thing to do to sub, especially for a double period. So yeah, I really appreciate it, whoever it is that is subbing for me. And guys, please behave for that person because it's not always an easy thing to do to sub. So without further ado, let me start by showing you guys a picture of my brand new baby, Carmelo Sebastian Morales. We're all doing great. None of us are sleeping very much, but that's pretty normal. You can probably hear how tired I am just from my voice. But yeah, I wanted to do a video just to go over some problems similar to ones we were doing before we went to break. So you should have a handout, and I'm going to walk you through number one, and then you're going to work on the rest yourself. Feel free if you get stuck at any point to send me an email with a question. I'll do my best to respond. Okay, so we have a rock. I'm going to draw it up here of mass 2.5 kilograms. This rock is 20 meters high. And the initial gravitational potential energy of the rock is given as 490 joules. So let me just draw this right here. Okay. So you should have actually been able to figure out the initial potential energy without it being given, just because PE equals mgh. Please write all this out. PE equals mgh, and you have m and h, and you know what g is, so it's 2.5 times 9.81 times 20. That should come out to somewhere around 490 joules, okay? So initial potential energy of 490 joules. Now, what are we going to do with that information? We are trying to find the final velocity of this rock being dropped. Okay, so when this rock gets to the moment before it hits the ground, what is the final velocity? Now, we know basically that if this rock starts from a complete standstill, the initial, let me write this as PE initial here, PEI here again, just as a reminder, PEI here means PE initial. So the potential energy that it starts with, that takes into account the mass of it, how high it is, and obviously gravitational acceleration, which is 9.81 meters per second squared. When you multiply all three of those things together, you get the initial potential energy. Initial potential energy here is 490 joules, and we're assuming that the rock is not moving in the beginning, okay? The rock is not moving in the beginning. So if initial potential energy is 490 joules and the rock is not moving in the beginning, that means it has no kinetic energy when it starts. There is no kinetic energy when the rock is initial. So let's put KEI is 0. Okay. Now energy is conserved. So by the time the rock gets close to the, like at the very last moment before it hits the ground, let's switch to red here for a second to talk about the final values. Right before the rock hits the ground, the height, the final height is 0. So let me actually really quick just put height initial, and height final is 0. The moment right before the rock hits the ground, the height final is 0. And after that, nothing else really matters because PE equals mgh. So we know that PE final is 0. Okay. Now, why are we talking about all of this? We want to find the final velocity, and what we're going to need to do for that is use the final kinetic energy. That means basically, since KE initial equals 0 and PE final equals 0, when we have this equation, that is PE initial plus KE initial equals PE final plus KE final. We should have remembered this. If you don't have this in your notes, please make sure you get it down. It is basically just saying the amount of energy never changes. The amount of energy in this rock never changes in its path towards the ground. Some of it will be potential, like halfway through here, half of it's going to be potential, half of it's going to be kinetic. At the top, at the top up here, it's all potential. And at the bottom of down here, it's all kinetic. It no longer has any height, and it is moving, so it's all kinetic. Up here, it's no longer moving, or it's not moving yet, and it has all the height it's going to have, so it's all potential. Okay, now we know KE initial equals 0, PE final equals 0. Okay, so let's just cross these out of that equation. KE initial, boom, get rid of it. I'm going to do that in red, actually. KE initial, boom, get rid of it. PE final, boom, get rid of it. We have PE initial equals KE final. Now, for every problem we're going to have on this worksheet, it's going to be the same way. PE initial equals KE final. So whatever the potential energy that I give you is, or whatever the potential energy you calculate, oh, how did that happen? Whatever the potential energy you calculate using mg and h, that's going to be the same as the kinetic energy final. Why do we need the kinetic energy final? Because kinetic energy is Ke equals 1/2 mv squared. mv squared. We know what m is. It's all the way up here. Right there. That's m. We know what 1/2 is because it's just a number. And v here is our golden ticket. That is what we are trying to find at the very end, right before the rock hits the ground. We are trying to find v. Okay? So we have v squared in this equation. And using that, we can calculate the velocity right before the rock hits the ground. Okay? So, PE initial is 490 joules. PE initial is 490 joules. We have it right here. It's given in the problem. PE initial equals KE final. Okay? We know that because KE initial is nothing. PE final is nothing. Okay? So, KE final just equals the same exact thing that PE initial was. This here equals 490 joules. And the other side of that, using this part right here, filling in what we know the mass is, 490 joules equals 1/2 times the mass, which is 2.5 kilograms, times v squared, okay? Times v squared. Now from there, it's just some simple algebra. We just want to isolate this v squared, get it by itself, get this v squared by itself, okay? So in order to do that, we're going to get rid of the 1/2 by multiplying both sides by 2 and dividing both sides by 2.5, just to get rid of these guys here. And then we'll just get, we end up with, let's see, v squared equals 392, okay? I'm running out of room here, but I'm going to jump onto the next page with that information. Let's see, does that make a new page? Yes, it does. V squared equals, what was it? 392. V is velocity again, okay? V squared equals 392. And from there, just take this, take the square root of both sides to get rid of this guy here. We want to get rid of this squared here. Take the square root of both sides. Oops, what am I doing? $392. And you end up with V equals 19.8 meters per second squared. Sorry, not meters per second squared. That would be if this was acceleration. It's just meters per second. Let's see, how do I make this smaller? Okay, that's fine. It's just meters per second. That's your velocity, 19.8 meters per second. What that means, again, is the fastest that this rock will go is 19.8 meters per second, okay? I know this is probably a bit confusing after coming back from break. Please feel free to work together on these problems as long as you're well behaved. I'm fine with that. The sub will let me know, okay? If you have any questions, again, let me know via email. The activity that I gave you guys yesterday and this worksheet will be due tomorrow, okay? So work through it for the rest of class, and I look forward to seeing you guys soon. Great.